Hi, so what I'm going to do in this video is start to show us one of the methods of differentiation which is key in advanced higher, and that is called the product rule. Okay, so what the product rule allows us to do is differentiate functions which are products of each other, so when they're multiplying. So we'll write the general formula. If you have a function y of x defined as f of x times g of x, as in two separate functions, the derivative can be defined as f dashed x times g of x plus f of x times g dashed x. Okay, so we'll break that down. What it is going to be is you differentiate the first and leave the second, and then add, leave the first and differentiate the second. Okay, so that's the product rule. So what I'll do is a few examples, and then I'll show you the way in which we can do this. Okay. So if we look here at this example, f of x equals x squared sine x. You can see that the first function is x squared, and the second function is sine x. Okay. So let's differentiate them individually because we know we're going to have to do that. So if I've got f equal to x squared, that means f dashed will equal to x. If I've got g equal to sine x, that means g dashed will equal cos x. Okay? So then f of x differentiated will be derivative times differentiate the first one, which is going to be 2x. Leave the second one. And then add, and then leave the first one, and differentiate the second one, which is cos x. And so that's actually the end of the question, because it's just going to be, although we could take out a common factor of x, which will give us x 2 sine x plus x cos x, to fully simplify it. Okay? So that's how to differentiate two functions when they're multiplying. So let's do another one. You can see the first function here is x plus 3 to the power 4. And then the second function is 2x minus 3 to the power 5. So let's differentiate them. So we've got 4 times x plus 3 cubed times the derivative of what's inside the brackets. Derivative of what's inside the brackets is just 1. So f dashed is just going to be 4x plus 3 cubed. G dashed will be 5 times 2x minus 3 to the power 4 times the derivative of what's inside the brackets. Differentiate what's inside the brackets, you get 2. 5 times 2 is 10, so it's going to be 10 bracket 2x minus 3 to the power 4. Now for the final answer. So it's the derivative of the first one times the second one left alone. Adding, leave the first one, times by the derivative of the second one. And I'll write that out fully simplified. We're going to have 4x plus 3 cubed 2x minus 3 to the power 5 plus 10 x plus 3 to the power 4, 2x minus 3 to the power 4. Okay? And if you really wanted to, you could take out a common factor to make sure it's fully simplified. So we look at what's common to both of them. We've got the number 2. We take out a common factor of 2. We can take out x plus 3 cubed, and we can take out 2x minus 3 to the power 4, leaving inside the brackets 2 and a 2x minus 3 and a 5 and an x plus 3. So we fully broke that out. We're going to get 4x minus 6 plus 5x plus 15. And then finally, to finish, (4x plus 5x is 9x). Negative 6 plus 15 is plus 9. Now it's got an extra common factor. I could take x, I could take the 9 out. Because when it comes to the final exam, it's going to expect you to fully simplify the function once you've differentiated it. Okay, so we're going to do one more. And we're going to look at this. Okay. So again, it's product rule, except you can see hopefully that we have 3 functions here. That's not a big deal. Okay. Let's just treat them individually. I'm going to treat the sine x because it's a trig function on its own, and I'm going to treat the x squared bracket x plus 1 cubed as a function within itself because it's a polynomial. Okay. So let's call f to be x squared x plus 1 cubed, and then call g to be sine x. Okay. And so here we have, within the product rule, we have product rule. So it's product rule within product rule. So you can see these are the basic methods for differentiation, but they add up and they add up, and you can be using them all interlinked. Okay. So differentiate the first, leave the second. Leave the first, differentiate the second. Times by the derivative inside the brackets, which is just 1. And so we get f dashed equal to 2x cubed squared. There. Which again we could simplify out by taking out the common factor of the x and the x plus 1 squared, leaving there, 3x. Nearly made a mistake there. So g dashed will just be cos x. And there we see we've fully factorized this all out. Okay, so now f dashed x, if we differentiate this first one, we've fully got this. So we'll have x bracket x plus 1 squared bracket 2 bracket x plus 1 plus 3x times by leaving the first one, all adding, leave the first one, differentiate the second one. Okay, and then we can see if we can do anything to simplify it. Well, what we can do is take out the common factor of x plus 1 squared. Which is going to leave inside the brackets 2 bracket x plus 1 plus 3x sine x plus x bracket x plus 1 times cos x. Okay. There, that's that. Fully differentiated it. Okay, so you can see that they can very quickly get complicated. But as long as you remember your product rule, then you're going to be fine. Okay?